All right, there we go. Okay, so on what day was it? Friday? The last time we learned, the last time we were in class together, last time we talked, we learned this theorem at the very, very end, but I wanted to like save the exercises to give us kind of a jumping start point for today's lesson. And so this theorem, again, we talked about already. You already have this filled in. It says in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So that's saying if segment AB is congruent to CD, then segment EF is congruent to EG and vice versa. So again, this whole worksheet has been conditional, converse, just switching back and forth. So again, looking at the picture, if I know, say that EG and EF are congruent, if that was given to me, then I can know that AB and CD are congruent. Vice versa. If I was told that AB and CD were congruent, then I get to know, then I can infer, then I can assume EF and EG are also congruent. So it goes both ways. So we're going to do these problems right here. These are pretty self-explanatory. The first one says in circle H, PQ is 3x minus 4 and RS is 14. Find x. I did not label PQ and RS just so we didn't get confused with segments or arcs or lengths, or is it the whole thing or the part of the thing? So that's why it's written up here. I do know, however, that TH and HU are both congruent to each other. They're both 8. Because those distances are the same, that is the distance from the center to the chord on both sides. The distance from the center of the chord, distance from the center of the chord is both 8. So then that means I get to know that PQ is equal to RS. Those lengths are going to be the same. Now, you don't always have to write a little equation like this. I think it's helpful, especially on this picture, because I'm not really sure how to draw PQ is congruent to RS, because that just looks like to me QT and RU are congruent. I want to show the whole thing. So I use this equation to demonstrate that. And then I plug in my pieces. So I know 3x minus 4 equals 14. Add 4 to both sides, 3x equals 18, and then divide by 3, x equals 6. All it said was find x, so we're good, done, ready to move on. Anybody questions yet? All right, do the same thing over here. This one says in circle A, WX is equal to XY, which is equal to 22. It truly doesn't matter that they're equal to 22. It just matters that they're equal to each other. So I'm going to use this highlighter to show WX and XY are both congruent. They're the same. Their lengths are equal. The end. Because the chords are congruent, because the chords lengths are equal, then I can know that my distance to the center are also equal. So that means, again, if I want to write it in symbols, AB is equal to AC. So I can write 5x. Ooh, I'm so sorry. Go away. 5x equals 3x plus 4. So I'm going to minus 3x from both sides. I get 2x equals 4. And then I divide by 2, x equals 2. Now, this problem doesn't just say find x, it says find AB. So we got to plug and chug. AB is 5 times x, so it's going to be 5 times 2, which my answer is 10. Make sure you read the problem and that you set it all the way equal to what you need to finish solving for before you're finished, okay? All right, any questions yet? All right, we got another theorem. This one says, in a circle, a diameter is perpendicular to a chord if and only if it bisects the chord and it bisects the arc. Okay. So, and I'm using the symbols here. So it says DE is congruent to EF. Those are the chords. So then that means that the arcs are congruent. DG is congruent to GF. I think it's F, not E. And I put the little chords there to symbolize that they're the chords, not, or excuse me, the arcs, not the chords. Segment versus arc, segment versus arc, chord versus arc. All right, so if we look at the picture, we're given one thing. In the first one, we're given that we have a 90-degree angle. So if it's 90 degrees, if they're perpendicular, then DE and EF are congruent and DG and FG are congruent. Vice versa, if I know that CE and ED are congruent, that means that AC is congruent to AD, and it also means that I've got a 90-degree angle here. Remember also with 90-degree angles, all four of these are 90 degrees. Because of linear pairs, because of vertical angles, those were skills we learned day 2 of class, they still come up. I only need to show one, but assume they're all there. All right, so we're gonna use that concept, and in this problem, we're actually gonna have to draw a couple new things. Not the first one, but the second two, we're gonna have to draw some things. I don't wanna do this one right here, this bottom right one. I'm gonna skip that one today. I don't wanna do that. Let's start with an easy one, a little softball, and then we'll do a little bit harder. So this one says in circle S, a measure of PQR is 98. So measure of this whole arc, PQR is 98. It says find measure of PQ. So it's just half of it. It's just this part right here. Because I know I've got 90 degrees, I know that these are congruent to each other. I know PQ is congruent to QR. And if it was helpful, it's not, but I could use it if it was helpful. I also know that RT and PT are congruent. What's helpful to me is that PQR can be split in half at Q. So that means that each of the little pieces are X. So I can think of it as 2X equals 98. And I can just divide by 2 to get half of that, to get from P to Q or even from Q to R, just divide by 2. In my notes, I just wrote 98 divided by 2, but I thought for you guys, I'd give a nice pretty equation. But you can just simply write this and solve it out if that makes you happy. When I do 98 divided by 2, I get 49. And so that is X, or we could label it as measure of arc PQ. Sorry, that's a little messy. Anybody concerns yet? Okay. The next one says in circle R, find TV. So we want to find this entire length T to V. I know that TS and SV are congruent because I've got a cute little 90-degree angle here, but that's not really helpful because I don't know how much either of those little pieces are or the whole length. So that's not super helpful. What I do know is that this length UR is split into 2. One of them is 5 and one of them is 6. I'm actually going to use this and I'm going to make a new triangle. I'm going to make a little triangle right here. I know that I've got this is 90 degrees, so this is also 90 degrees. I know SR, this bottom side is 6. Does anyone know how long TR is? What's that going to be? Anyone know what that length TR is going to be?
Is it 12?
It is not 12. We're getting close. Anybody else have a guess?
Is it 11?
It is 11. The reason it's 11 is because, and it's not 12, is because I don't know if TS cuts the length of UR in half. I don't know if it's going to be 6 and 6, but what we know is that from the center to the outside, that's the radius, and that's 5 plus 6, which is 11. So it's 11 up here, it's 11 over here, it's 11 no matter where I go in my circle. And so the triangle that I drew means that this hypotenuse, this long side, is going to be 11. Let me draw my little triangle off to the side just so I can keep everything straight. This is 11, this is 6. We don't need this part over here that was also 5, but that did help me find where 11 was. And I want to find this length right here. That length goes from T to S, And if I can double it, that will give me the entire TV length. Does anyone know how I would find X? What method would I use to find X? What method would I use to find X? Anybody know?
Is that where you square them all?
Mhm.
Is that trig? Is that what it's called?
It's not called trig. We learned about it in the trig chapter. I'm looking for the word Pythagorean theorem, but you're right. You square it all. So Michael's right with the concept. We're squaring everything. The thing is, you need to remember 11 goes by itself, so it's going to be x squared plus 6 squared equals 11 squared. X squared stays by itself, 6 squared becomes 36, and then 11 becomes 121. Minus 36 from both sides, and we get 85. Now, we're going to have to square root both sides to get x by itself. I got to make a little factor tree to see if I can simplify 85 anymore. I think that's 15 and, or sorry, 5 and 17. Yeah, that's right. That's right, but it's not helpful, right? Because I don't have anything I can take out. So my best answer is going to be root 85. Now that's just the length from T to S. And so we need to double that. We need to multiply it by 2 to get the length from V to S. So I'm going to do 2 times root 85, which if it said leave it exact, I would want an answer that says 2 root 85. But I don't. I want to round to the nearest 100th. So let's get our calculator out and let's figure out what this would be if I plug it into the calculator. So I do 2 root, oh, that's the wrong button. 2 root 85, and then I press enter. And I get 18.4390889, blah, blah, blah. It says round to the nearest 100th, which is 2 places after the decimal. So I better round that 3 up to a 4. And my answer, my best answer, because it says round to the nearest 100th, is 18.44. Okay, we got one more problem like this, and then we got another theorem. Anybody any questions yet? Okay, let's look at the last one of this type. This one says find y. Oh, and this looks a lot like the last problem we just did, but we didn't even have to imagine a triangle. My triangle is actually even drawn already for me. Something like this. Because I know AC and CF are the same length, I get to have a right angle in here. I know one of my sides is y. I know one is 11. And then what's this last side going to be? Anyone know what this last side is going to be?
Is it 4?
Not 4. AB is this length. You can think about it going all the way around my triangle. What's the distance from the center to the outside?
15.
15. It's my radius, right? They even showed me my radius. They just didn't label the segment that I wanted. So I want this to be 15. And again, you can draw your little triangle off to the side, 11, y, 15. And then again, use Pythagorean theorem to find y. 11 squared plus y squared equals 15 squared. I got 121 plus y squared equals 225. Then we do 225 minus 121, which is 104. Now this is good practice to do regardless, but since this one does not say round it to the nearest 100th, go to the 10th place, give me the nearest number. Like this doesn't say anything. So we're going to find the exact value, which means we're going to do our square root, our little factor tree, and then we're going to leave it in that form. So let me do my little factor tree off to the side. I'll do 104 down here. 104, let's start by dividing by 2. That becomes 2 and 52. Okay, now 52 can go by 2. Okay, it becomes 2 and 26. And then 26 becomes 2 and 13. Okay. I know I'm a little bit in the words for the next one, but that's okay. Let's look at just these numbers. These are the numbers that repeat or that factor down. So I got 2, 2, 2, 13. I have one pair of 2s, so I get to take that 2 out. But my other 2 doesn't have a partner, so he stays underneath. My 13 doesn't have a partner, he stays underneath. So I'm going to make my radical 104 become 2 radical 26. That is my best answer. Anybody have any questions so far? All right. Okay, the next part is a definition. I've talked about these words before, but now they're actually in a definition. I know I just wrote all over them. Let me erase that so we can read them. Hopefully you did not write all over them like I did. There we go. Okay, I don't need that anymore. Go away, bye. Okay, so my definition, my sentence says, if all the polygon's vertices lie in a circle, then the polygon is said to be inscribed in the circle, and the circle is circumscribed about or around the polygon. So a polygon, remember, is a shape with many sides. It has vertices or the corners. I like to think of them as like the little corners of the shape. Then the polygon is said to be inscribed. And again, I used this word last week, I think, and I told you it's the same as like inside. That polygon is inside the circle where all of the points that are the vertices of that shape are on my circle. And then we talk about the circle being circumscribed about. Remember the word circumference is around the outside of the circle. It's like the distance around. Circumscribed means to be drawn around or about or outside. So next to circumscribed, I'm going to write outside or around or about. I know those are prepositions and not necessarily like real words, but I think saying something is around something else is a pretty decent descriptor. So the last 2 theorems that we have rely on us remembering what the word inscribed versus circumscribed means. All right, so the second to last theorem, this one right here, it says if a right triangle is inscribed in a circle, then its hypotenuse is a diameter of the circle. So if a triangle is inscribed in a circle, then its hypotenuse is a diameter of the circle. So because of the way it's physically drawn, if all my points are on the circle and I have a right angle, then the only way for that mathematically, physically to work is for my hypotenuse to also be, oh, I did not mean that. My hypotenuse is the same thing as the diameter. It goes right through the center and it goes all the way across the circle. Now, going off of that, this theorem kind of like goes hand in hand with this one. It says if a triangle is inscribed in a semicircle, then it's a right triangle. So if I have just a semicircle, so if I've got like the diameter, if I like cut my circle in half and I just have this half a circle, and I have a triangle inscribed in this, then it has to be a right triangle. The only way for it to work is for both of its edges to be on the circle, and the bottom of it becomes my diameter. And then wherever else this point goes, it's still going to be a right triangle. Even if, let's see if I can draw an example. No matter how this triangle looks, this is always going to be a right angle. This point that I'm moving around will always be at a right angle because of where its base or the bottom of its triangle is. We could get way more in depth with it, but we don't really have time to right now. So just trust me or come to office hours and ask me and I can try and explain it a little bit better there. All right, I'm going to do examples 1 and 2 with you, and then you're going to try 3 and 4, and then we're going to look at the last theorem together for today. All right, I got to find x, measure of angle x. In order to do that, I need to remember the theorem we just learned. If this is the diameter and it's also the hypotenuse or a side of my triangle, then I can know that this is a, ooh, that was terrible. This is a right angle. If that's a right angle, then I can add all my angles up, set them equal to 180, and I can solve. X plus 12 plus 90 equals 180. X plus x is 2x, 12 plus 90 is 102. 180 minus 102 is going to be 78, I think. Yep. And then I divide by 2, and I get x equals 39. Anybody complaints on that? Okay. Then to find w, plug and chug. 39 plus 12 going to be 51. All right, take a second, look at 3 and 4 on your own. I'm going to jump in with you in a second. Try 3 and 4 on your own. All right, if you're waiting for me, let's finish up this problem. Remember that angle S has to be a 90-degree angle because I have my one side of my triangle counts as the diameter. That makes the other angle S has to be 90. Add them all up, set them equal to 180. I'm going to do them over here. So I've got 2x plus 4x minus 6. Don't forget to add that 90 in. Earlier this morning, I completely forgot to add my 90 and it changed my whole problem. Because 2x and 4x minus 6 felt like enough things, I was like, oh, I'm done. I've added everything together. Don't forget your 90. It's going to make a big difference. 2x plus 4x is 6x. Negative 6 plus 90 is 84 equals 180 minus 84, and I get 96. And I believe I get 16, but I could be wrong. Yes, okay. Divide by 6 on both sides, and I get 16. And then the last thing says measure of angle T, which is 4x minus 6. So I'm going to do 4 times 16 minus 6. And that gives me 58. And put a little angle next to him, little degree sign because it's angle T. Everybody doing okay with that so far? Okay. All right, again, this last theorem we're going to learn, and I think the first 2 examples are very straightforward, very simple. You'll get them right away. The last one's going to take some algebra, and we're going to do that one together momentarily, but let's do the easy ones first. Okay, so the theorem we just learned was about triangles. This one is about quadrilateral, so 4-sided figures with 4 corners with 4 vertexes. It says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Remember that supplementary means that they sum to 180. And it says opposite angles. Not the ones we want to be supplementary, they have to always be opposite angles. That's going to make sense in a second. So an opposite angle could be A and C. So measure of angle A plus measure of angle C needs to equal 180. Another example would be B and D. Measure of angle B plus measure of angle D needs to equal 180. So let's put that over here. I'll do this one first. I've got measure of angle B plus measure of angle D equals 180. And I just colored them pink so you could kind of see where they correlated on my picture. I like to color coordinate if I can. Measure of angle B plus measure of angle D equals 180. And I'm going to do the same thing with C and A. So measure of angle A plus measure of angle C equals 180. That's all it's saying is you take the opposite angles, set them equal to 180. Take the opposite angles, add them up, set them equal to 180. Now, my first two examples are easy because it makes sense. You're okay with doing it. It's not kind of contrary to what we think it should be. So let's do those. The first one, I've got 2x plus 100 is going to equal 180. All right, no complaints. We can do that. Minus 100, 2x equals 80. Divide by 2, x equals 40. Okay. Any questions on that? And no complaints, right? You're like, math seems fine. Same thing, we're going to do y. We're going to do y plus 87 equals 180. So we just minus 87 from 180, and I'm going to get 93. It's cake, right? Easy, easy, easy. Next one's very similar. Let's look at that one. Anybody questions so far? Am I moving too fast? Everyone good? Okay. All right. Similar idea here. Again, opposite angles go together. So I'm going to do 2x and x plus 18. Okay, that seems fine. 2x plus x plus 18 equals 180. So that becomes 3x plus 18 equals 180. Going to minus 18 from both sides. We get 162, and then we divide that by 3, and we get 54. X equals 54. Next, we're going to do our y's. I've got 3y minus 7 and 3y plus 1. Again, those are opposite angles. X and z are opposite angles. They're supplementary. This is all fun and games. 3y minus 7 plus 3y plus 1 equals 180. 3y plus 3y is 6y. Negative 7 plus 1 is minus 6. Add 6 to both sides. Y equals 186, and then 186 divided by 6 is 31. Oh, I just realized I completely forgot to do this during my other classes, so we'll just fill these in. Sorry, A period and C period. That's my bad. I don't know how I missed those. Yikes. All right, so to find W, I'm just going to do x plus 18, because that's what the expression for W is. X plus 18. So that's 18 plus 54. That gives me 72. And then it also says find measure of angle X, which is 3y minus 7. So 3 times 31 minus 7. 3 times 31 is 93. And then minus 7 is going to be 86. Now, these two angles don't have to be supplementary because they're next to each other. X and Y are like next to each other on my picture. They're not opposite across from each other, so they don't have to add up to 180. So technically there's no checking I can do right now unless I also found Y and I also found Z. Okay. Anybody, any questions yet? Okay. The last problem, again, we will spend more time on this. There's one problem like this at the very end of your homework. You can skip it. We can look at it tomorrow. I don't know if I just said that, if I've said that already, or if I just thought that in my head, but that's what's going to happen. The reason that I want more time with this, but I also am ready to test everything else because I don't want another review online. I want to get this done. I want to move into chapter 11. I want to get close to a final as much as possible and not have to draw this out anymore. This is algebra skills, because when I'm going to set my opposite angles equal to each other, it's not going to be nice and pretty like I want it to be. Okay. So like angle U is 21y. Well, we normally want the other y to go with it, but R and U are not opposite angles, so I can't add those up equal to 180. I have to do the true opposite, which is over here at S. So I have to do S and U together, which is 12x and 21y. I'm gonna write that down. It's gonna feel funny. 12x plus 21y equals 180. And that's a true statement. Even though it feels funny, I can't simplify it, I can't solve it super easily, it's still true. Same thing for the other opposite angles. This time I've got 8x and 29y. Again, no, not two x's, not two y's, but they're my opposite angles. And so I have to put my opposite angles together, add them up to be 180. So this is going to be 8x plus 29y equals 180. Okay, I need you to go back to the depths of your brain and brush off the algebra part. And I need you to find systems of equations back in the depths of your brain. We're going to do what we call elimination, which means that we're going to eliminate, we're going to get rid of one of the variables. And I want to get rid of x. One of them's 12 and one of them's 8. Okay, the easiest way to do this, we have to multiply either one or both of the equations by something in order for 12 and 8 to cancel out. In this case, there's nothing I can multiply by 8 to get 12, so I'm gonna have to multiply both the equations. The easiest thing is to just take the opposite coefficient of my x and multiply it by the other equation. So like I've got 8 on the bottom, so I would multiply the top equation by 8. Then on the bottom, I would multiply that by 12 because 8 times 12 should be the same thing as 12 times 8. Now that's going to get to be really big numbers and I didn't want to deal with that. So you're welcome to continue, like just not listen to anything else I say and solve out this way. The only other thing I would add is you need a negative in front of one or the other. However, I don't want to use 8 and 12 because I want to do smaller numbers in case I mess up. I don't want to do 8 and 12. I feel like there's a lot of room for error. Instead, okay, what if I did 2? 12 times 2 is 24. Well, can I multiply 8 by something to get 24? Yeah, right? 8 times 3 is going to be 24. So 2 times 12 is 24x. And then negative 3 times 8x is negative 24x. And when I do positive 24 minus 24, those two cancel each other out. So I could have done 12 and 8 and multiplied those guys, but I'd rather do 2 and negative 3 and then have smaller numbers to deal with. All I have to do now is distribute 2 to everything in the first equation and negative 3 to everything in the bottom equation, and then add up my columns, solve for y. Okay, I already have my first ones out. Then I've got to do 2 times 21y, which is going to be 42y, and then 2 times 180 is 360. Then I'm going to do negative 3 times 29, and that's negative 87. Oh, I'm sorry. Negative 87y, and then 180 times negative 3 is going to be negative 540. Okay. All right, we've decided the x's cancel, so I combine my y's. 42 minus 87 is going to be negative 45y. And then 360 minus 54 is negative 180. And then I get to do negative 180 divided by negative 45. Oh, nice. And I get y equals 4. Anybody have any questions yet? Anything about systems, anything about setting this up? Any questions? Okay. I can plug my y into either one of these original equations, or technically you can plug it into one of your new equations. That still works. It doesn't matter. It just is bigger and can get messy, but it works. I'm going to just plug it into the top one. Again, it does not matter. If there's one that feels like it fits better, then do that one. So I've got my first equation again, but instead of writing y, I'm going to multiply by 4. So I've got 12x plus 21 times 4 equals 180. So I've got 12x plus 84 equals 180. I'm going to minus 180 minus 84. And I'm going to get 96. And then 12 divided by 96 is going to be 8. Now, it said solve for x and y, and then it said find the measures of each angle. So we're not done just because we found x and y. We have to use those. X equals 8, y equals 4. So every time we see x, we get to use 8. And every time we see y, we get to use 4. So I'm just going to plug them in and find out what all my angles are. So first when I see 8x, 8 times 8 is 64. Then I see 12x, 12 times 8 is 96. Then I see 29y, 29 times 4 is 116. And then I see 21y, and 21 times 4 is 84. Again, if you want to check your work, you can see that 84 plus 96 is 180. It is. And then you can also see if 116 and 64 is 180, which it also is. Okay. Anybody have any questions yet? Okay, I want to preview your homework really quick because I said this and I don't know if I said it earlier in class or I just thought it or said it to my other class, but your homework is online already. It's already got a little attachment. It's already an assignment. I'm trying to be on top of my game for these last couple weeks, but it's 3 sides, but I want you to skip this third side. I want you to download it if you're doing it online or print it off if you're doing it on paper, but you don't have to have this one done for tomorrow. We'll look at this one together to do another example all together. Again, I'm going to have to do systems with this guy, but you are required to do everything up to 17. So 1 through 17, you must have done. You need to have that turned in by Wednesday. And then we'll do the last part together and we're going to review on Wednesday. I actually just recently found out that my meeting tomorrow is canceled. So if you want to talk tomorrow morning for office hours or Wednesday morning or Friday morning, those are 3 times that I can meet with you before your test on Friday. And then other than that, we're just kind of in the full swing of the end of the year. So if you're not happy with your grade, we got to figure that out real fast, what we got to do to fix it. I'll stay on for the last 5 minutes of class, but you guys are free to go. If you need anything, let me know. If not, enjoy your day, get your homework done. Come talk to me if you need help. Bye.
Thank you.
Thank you.
Thank you.
Thank you.